Thus far, whenever we have talked about the force of friction, that friction value has been given to you. 160 newtons, 180 newtons, whatever it may have been in previous problems. However, we don't have to merely be given a force of friction. We can actually calculate a force of friction. So let's talk about all the different things that come into play when we think about friction. Now, if you've ever heard the phrase, it's hard to get something moving, but it's a lot easier to keep it moving, that is totally true, especially when it comes to friction, because it turns out that there are two kinds of friction. There is static friction, which is the friction force between two objects. When they are not sliding against each other. And then there's kinetic friction. That is the friction force between two objects when they are sliding against each other. You guys took data for both static friction and kinetic friction in your lab. So if we want to think about what the friction force depends on, it depends on two different things, and this is what we discovered in your lab. The magnitude of the force of friction depends, number one, on the normal force, and number two, it depends on the surface type. What kinds of surfaces are rubbing against one another? When we think about these two things, they can come together and be expressed as an equation, and that is the equation that we found out of your lab. The force of friction is equal to the coefficient of friction multiplied by the normal force. Now, if you notice, on the right-hand side of the equal sign, there are two things. There is the normal force, and then that coefficient of friction, the Greek letter mu, that represents the surface types. Because we can't have a number for something like tile or countertop or grass or denim, but we can have what is called the coefficient of friction. So let's remind ourselves what that mu represents. It represents the coefficient of friction. So FF equals mu Fn. It applies whether we are talking about static friction or we are talking about kinetic friction. So this is great. We have one equation that we need to know for two different situations. That's wonderful. We love that. But one thing to always remember is that static friction is always greater than its corresponding kinetic friction. So for an example, if you have a book and it is sliding across a table, the amount of friction it takes to get the book started will always be greater than the amount of friction that is acting on the book once it is already moving. Well, why does that happen? Well, you have to go back to chemistry class. And if you go into the bonds, right, so if we zoom in right here, and we take a zoomed in look at the book and the table, well, the book and the table suddenly are not very smooth anymore. They have all these weird peaks and valleys and all that stuff. But most things are made up of the atom hydrogen. And when hydrogens hang out with other hydrogens, you may remember from chemistry class that they end up bonding. So these hydrogens are all going to bond together, and we have to break all of these bonds before we would be able to get the book and the table to move relative to one another. Breaking these bonds is what creates static friction. That's why we need that force to overcome static friction, so that we can break all of those bonds. And that's why it is always going to be greater than kinetic friction. All right, in the next podcast, or sorry, vodcast, we'll be doing some practice problems with friction.